In the previous video, we looked into the laws of indices and the logical reasoning behind them. So in this video, we're going to use those laws and simplify some algebraic fractions. So if you haven't watched that last video, I highly recommend that you do so. And you can find the link to that video at the top right corner of your screen or in the description below. So let's start with question number 1. 3a squared b times 5ab squared times 10c cubed. As we've already seen a couple of videos back, when we are multiplying two algebraic terms, we multiply the coefficient with the coefficient and the variables with the variable. So to make it more clearer, I'm going to break these algebraic terms into its constituents. So 3a squared b is basically 3 times a squared times b, and then times by 5ab squared is simply 5 times a times b squared times 10c cubed is basically 10 times c cubed. Now since multiplication is commutative, you can reorder the terms as you want. So what I'm going to do is I'm going to take all the numbers together, all letter A's together, letter B's together, and letter C together. Right? So let's do that. 3 times 5 times 10. So I'm going to take 3 times 5 times 10 together. So this 3, this 5, this 10. I'm just reordering in a way that I get numbers together and then a terms together. So I'm going to say times a squared times a, and then I'm going to put the b terms together. So times b squared, and then there's only one c term left, so times c cubed. Now we can simplify that. 3 times 5 is 15 times 10 is 150, and then a squared times a. Now this is where our laws of indices come in. As we saw in the previous video, we know that when the bases are same and when indices are multiplied, the powers add. And we know that the power here is 1. So when there is no power written, that means by default there is a 1. Bases are same, a, and they get multiplied. So the powers add. So this is basically a cube there. So times by a cube. And then we have b and b squared. Again, there's a power 1 here. So when you multiply b and b squared, same base multiplies. The powers add, that is times b to the power 3. 1 plus 2 is 3. And then I have c cubed. We don't have any other c terms to multiply with, so we're just going to write that down here. The answer now can be written at once as 150 a cube b cube c cube. You can also write this as 150, and you can just put them into one bracket a, b, c, and then say cube. This is not necessary though, but I'm just showing you an alternative way to write the same answer. So I just broke each algebraic term into its parts just to make you understand how it actually works. But when you're doing it in a test or an exam or in your class, you don't need to do this. You can easily multiply the coefficients together and variables together of the same base. So what I would do generally is 3 times 5 times 10, that is 150. And then a squared times a, that is a cube, b times b squared, that is b cube, and then c cube. This is how I would ideally write. So I wouldn't go disintegrate each part or each algebraic term and then group them and then do them. I just did it here to show you guys what's going on actually in there. So hope this way made you understand a little bit more of how that multiplication is actually happening. Alright, now let's move on to the second question. It says 2x squared y times 5y squared divided by 2xy squared. So let's simplify the numerator first. So the numerator is going to be multiply the coefficients. 2 times 5, that is 10. And then there is a x squared. There is no other term to pair with, so that's just going to be x squared. And then this y and this y squared is multiplying. So y times y squared, when you say y, it's actually y to the power 1. So since the bases are same and they're multiplying, the powers will add. 1 plus 2, 3. So that is y times y squared is y cubed. And then let's now write the denominator, 2xy squared. Now what is happening here is we are dividing, and when we divide indices with the same base, the powers subtract. So we say 10 divided by 2 is a 5, and then x squared divided by x, basically that's x squared divided by x to the power 1. And the bases are same, both are x. They are being divided. The powers will subtract. So it will become x to the power 2 minus 1 is just 1. So that's just x. And also when you look at y cube and y squared, same base, powers will subtract 3 minus 2. So 3 take away 2 is 1. So that's just y. So that's the final answer. So now let's go to the third question. 10a cube b times 2bc squared divided by 5a squared b squared. So this question is just like the previous one. So if you want to, you can go ahead and try it out. You can pause the video and try out the question by yourself and then resume it to see how it's done. So let's solve the question. So we'll simplify the numerator first. 10 times 2, the coefficient, they multiply together. So 10 times 2 is 20. A cube, and there is no other a in the second term. So that's just going to be a cube. B times b is just b to the power 1 times b to the power 1. So b to the power 1 times b to the power 1 is b squared there. And then we have c squared, and we don't have any other c terms to pair it with. So we're just going to go ahead and say c squared. Now let's write down the denominator, 5a squared b squared. Now let's divide. 20 divided by 5, that is 4. And now let's come to the a terms. A cube divided by a squared is same as saying a to the power 3 minus 2. The powers will subtract. That's just 1. So that's a to the power 1, or just a. And then we have b squared and b squared. So b squared divided by b squared divided by b squared. This is just b to the power 2 minus 2, which is b to the power 0. And according to the fourth law, we learned that any number to the power 0 is just 1. So b to the power 0 is 1. We don't need to write 1 here because we are just multiplying. So in a multiplication, 1 doesn't have any contribution because anything times 1 is itself. So the b term entirely got cancelled off. So b squared subtracted b squared, and there is no more b terms now. And c squared, that's alone. It doesn't have anything to subtract. So we're just going to say c squared. Right, let's go to the fourth question. 4p squared q times 5pq cube, right, divided by 15p squared q squared times 2qp squared. So first let's simplify the numerator on top. So that is just 4 times 5, coefficients getting multiplied together, that is 20. P squared and p, that is p to the power 3. Q to the power 1 times q to the power 3, powers add, so q to the power 4. So that is the simplified version of the numerator. Now let's go to the denominator. 15 times 2, the coefficients, that is 30. P squared and p squared, that is 2 p squareds here, p squared, multiplied together will become p to the power 4. Powers will add, 2 plus 2 is 4. Q squared and q is just, when multiplied together, the powers will add, so that's just q cubed. Now let's simplify the numerator and denominator. So first let's look into the coefficients. 20 divided by 30. So 20 divided by 30, that's just 2 by 3. So let's write 2 by 3. 2 by 3. P cube and p to the power 4. Now if you think about this, p to the power 3 and p to the power 4, the larger number is at the bottom. So if you use the law, what happens is p to the power 3 divided by p to the power 4, that is equals to p to the power 3 minus 4, which is p to the power minus 1 or negative 1. And to make the power positive, we will send the p down and it will become 1 over p. Or we can think about it like this. P to the power 3 is same as saying p times p times p. P to the power 4 is saying p times p times p times p. So when you're dividing, 3 p's at the bottom will cancel off with the 3 p's at the top, leaving 1 p at the denominator, which we say as 1 over p. So the answer you get is anyway the same, which is a p will be remaining in the denominator. So there is a p left in the denominator. Q to the power 4 and q to the power 3. The highest power is at the top, so no problem. 4 minus 3, it's just q. That's just q. So 2q over 3p. That's the answer for the fourth question. Finally, for the last question, so let's go ahead and simplify the numerator. Before we multiply the coefficients, you can observe that there is a power outside the bracket. So we'll have to solve that first. So this power 3 over here, this belongs to this 2 and this a to the power minus 2. Likewise, this 2 over here also belongs to both the coefficient and the variable. So let's distribute that. 2 to the power 3, that becomes 8. A to the power minus 2 to the power 3, that's remaining. Now this is power of a power, the third law of indices. So the powers get multiplied. A to the power minus 2 times 3, that is a to the power minus 6, right? So that becomes a to the power minus 6 times by, and then we have the second bracket, 3 squared, that is 9, 3 to the power 2, and then a to the power minus 4 to the power 2, that is minus 4 times 2, that is minus 8, divided by, we will write that as it is, minus 3 and 2a to the power minus 2. Now we'll simplify the numerator. So the numerator is 8 times 9, 72, and a to the power minus 6 times a to the power minus 8. So that is a to the power minus 6 times a to the power minus 8. So according to the first law of indices, they add a to the power minus 6 plus minus 8. And that is just minus 6 minus 8, which is minus 14. So that's a to the power minus 14. Divided by 12 times 2, that is 24. A to the power minus 3 times a to the power minus 2, that's minus 3 minus 2 is minus 5 together when you add, so a to the power minus 5. So now let's divide. 72 divided by 24 is 3. 24 times 3 gives you 72, so 72 divided by 24 is 3. A to the power minus 14 divided by a to the power minus 5. A to the power minus 14 divided by a to the power minus 5. That is subtraction. A to the power minus 14 subtract minus 5. This is same as saying a to the power minus 14 minus into minus is plus. So that is minus 14 plus 5, which is a to the power minus 9. So the answer is 3a to the power minus 9. Now if you see, the power is negative 9. So to make it positive, we use the fifth law of indices. And according to that, we switch its position from numerator to the denominator. So we all know that there is a 1 as a denominator by default. So what happens is this goes and multiplies with the 1. Or basically you just switch its position. So 3 over a to the power 9. As you switch its position, the power will become positive. So that's the answer. Hope you understood these example problems. If you find my videos useful, hit the like button and consider subscribing. Also, please feel free to comment below if you have any questions or if you have any topics that you want me to discuss in the next videos. See you then.